Hello everyone, this is Mr. Precalc, and today we're going to start P9. We're going to look at using a graphing calculator to solve some problems that you already know how to solve algebraically. First of all, I want to remind you about solving inequalities and kind of step it up a small notch. Here where you see an inequality, a linear inequality with fractions involved. Just like any other inequality, you're going to solve it the same way you'd solve an equation. Just going to treat it as an equation. So in this case, remember we said we would multiply by we'd clear out the denominator, so we'd multiply by 6, or really what we're doing is multiplying by 2 times 3. And we multiply each expression, so the 2's cancel, so we have 3 times that, which is 3x minus 12. And over here, the 3's cancel, so that's 2 times that, so that's 2x minus 4. Over here, the 6 cancels, so that's just plus 5. And then we solve that, so we bring the x over, and we bring the 12 over, so there's a 1 plus the 12, and we get x is greater than or equal to 13, which in interval notation would look like this. So just like what we've been doing, only difference is there's an inequality sign. And of course, remembering that if you multiply or divide by a negative with an inequality, the inequality changes direction. Okay, now let's look at a linear inequality and how we would solve it using our graphing calculator. So you may need to pause to really make sure you're able to follow along with your calculator. I'm going to go kind of quickly here. So we could certainly solve this algebraically, but I want you to know how to do it with the calculator because it's going to allow us to do some things that are not so easy to do algebraically. So basically what I want to do is I want to know when this expression is less than or equal to this expression, when the output values or the y values for each of those. So I'm going to treat them like separate functions. So I want to know, right, so y1 is just what you get when you put something in for the x in this expression. y2 equals 7 plus 3x, the y value is just what you get. It's the output when you put something in for this x. So I want to know for particular x values that I could plug into both, when is this one going to be smaller than or equal to this one? And that's really easy to see on a graph. So let's go ahead and get out our graphing calculator. And we're going to go to the y equals screen, which is where we put equations in. Now I've already typed the 2 equations in, so y1 is my 2x plus 3, y2 is 7 plus 3x, and if I go ahead and press graph, I see that those 2 functions are graphed there. And hold on here, so this one, this is our y1, make sure I'm remembering that correctly. Yep, that's the 2x plus 3, so that's our y1, and this is our y2. So the question we're trying to answer is, I'm going to go back to this, when is y2 bigger than y1? In other words, when is bigger than or equal to? When is this one bigger than or equal to this one? So I just want to know when y2 is bigger than y1. So if on this graph, it's very easy to see that y2, if you pick an x value, let's say here, if I look down, the y1 value is higher than the y2 value, so it's not true there. y2 is smaller, it's lower. But if I go, let's say over here on the x, if I plug that x in, the y1 value is smaller than the y2 value. So the key point is where they cross, right here, okay? Because from here on, y2 is now bigger than the y1 values. Now, it's a little hard to tell exactly where that happens, so I'm going to show you how to use your graphing calculator to find out exactly where that is occurring. Sorry, I'm getting my tools out of the way. So what we want to do is have the calculator calculate the intersection. So I'm going to press second trace, which you notice up in blue is calc. So I press second trace, which gets me the calc. And I want the intersect. I want to know where these 2 things intersect. So I'm going to press 5 for intersect. Now it's going to ask me some questions. We only have 2 equations typed in, so this question is going to sound silly. But let's say I had 5 different equations on that y equals screen, but I can only find the intersection of any 2 of them. You'd have to tell the calculator which 2 you want it to find the solution for. In this case, it's kind of silly because there's only 2 choices. So it asks me first curve question mark. So y1, that's my first curve. Yeah, I know it's not a curve, but it treats all equations the same. So I'm just going to press enter to choose y1. Then it says second curve. Do you want that to be y2? I'll press enter again to say yes, I want that for my second curve. Then it asks you to make a guess. This isn't super important, but you do want to get it in the vicinity. So I'm going to move use the arrow key to move that cursor. And see that cursor there is close to where they intersect. I press enter, and voila, it tells me exactly where they meet. So when x is -4, both functions have a value of -5. So if I go back here, when x is equal to -4, both functions are the same. But what we saw from that graph is, as I go to the right, x values that are bigger than that, the y values for y2, these values up here, are bigger than these. So my solution then is all x values that are greater than or equal to -4, or in interval notation, -4 to infinity. And if we were to solve this algebraically, we'd get the same answer. And you can solve that algebraically to convince yourself, but you'd get that same answer. Okay, let's look at another example. Here's an absolute value equation. So let's take a look at how you would put that in. So again, I want to compare the left side and the right side. This time I want to see when they're equal. And again, you could solve this algebraically pretty easily, but I want to show you what it looks like on a graph. So let's take a look at our calculator and put in the absolute, the absolute value of x minus 6. I'm going to go to my y equals screen. I'm going to press clear to clear out the two equations that are there. And now I want to put in absolute value. Well, absolute value is not on one of these buttons. It's math, an easy way to remember it. So if you press math, and then it's a numerical expression or a numerical function. So I'm going to go over to num. You have to remember this, so you might want to write that down. Math, num, and then ABS for absolute value. And there's my absolute value, and it's going to be for x minus 6, and then I can press enter. And then the other side I'm comparing that to is just 12, just y equals 12. So our y2 is just going to be y equals 12. And I want to know when those two things are equal, because that's what we're looking for. So this is very easy to see on a graph. So we're going to graph that, but we have a problem, which is that we can't see y equals 12 in our window. So this is something you're going to have to get good at, which is adjusting your window to show you what you need to see. So if I press window, I'm going to change. Let's go back to that graph for a second. I know I need to go up to at least 12 on the y-axis because the y value is 12. Uh-oh, I'm going to run out of time here. I'm going to try and do this quickly. So we need to change your window so that the y values go up to at least 12. So I'm going to go up to 15 so I can see that. And the x values, I'm going to go out to, let's say, 20 just to see if that fits. And let's see if now we can see. Yep, see, now I can see where they intersect. And I see that they're in two places, here and here, which fits with what happens when we solve algebraically. We get two solutions. So you can calculate the intersection. Second, calc. Intersect is 5. Okay, first curve is the absolute value. Second curve is 12. And now here's where the guess is important. There's two different intersections, but the calculator can only tell me one at a time. So I'm going to move the arrow over. Move it over close to this one because I'm going to find that one first. And I'm going to press enter. And I see that intersection's at -6. So x equals -6 is one of my solutions. And to find the other one, I'm going to do it again. Second, calc, intersect, first curve, second curve, and this time I'm going to arrow over to the other way. It's a little annoying because you got to just keep arrowing over there, arrow over. Keep going, come on. Okay, keep going. And it's close enough. I'm going to press enter. And it shows me the other intersection, which is when x is 18. So there you go. Okay. One more thing I want to talk about here is what would happen if instead of equals 12, it was less than 12. So if I wanted to know when it's less than 12, this is really easy to see on the graph. Because where is my absolute value? Where is the absolute value of x minus 6 smaller than 12? Well, that's easy to see here. It's where it's underneath right? All this stuff under here is all less than 12. So it's from here to here. It's x values from, that was -6 to 18. So the solution is any x value from -6 to 18. So we'll get into that more tomorrow, but that gives you a little taste of how to use your calculator to answer some questions, and that's all for today. Thanks.